So you're opening up Studio with a great game idea, ready to make it quickly and hit the front page just to start building the map and realize you really don't know anything about how to get the game to actually work. Then maybe you searched up how to script on Roblox.
Tree. Now, Vector Tree is
But you were extremely confused by all the mumbly jargon in all the videos and just ended up spamming your keyboard on your script before picking up a hammer, smashing your computer and kicking your monitor in and slowly throwing your computer out a window and driving your car. It's safe to say that might have been the last day for some of our computers. But don't worry about it, because I am here to help, because I was in that tragic situation just a year ago. But I managed to learn scripting eventually after starting as a builder and having barely any idea what I was doing, just like you. This guide is going to explain you how I learned to script in the simplest way possible, and I can guarantee you'll be able to script by the end of this video. You're gonna need to open up Roblox Studio, of course, and we're gonna make a base plate, just a normal old base plate, and we're actually not gonna make a script first. We're actually gonna build something first. Well, we're just gonna place one part down, but it kind of counts. So I'm just gonna delete the spawn location there. Let's close out toolbox. We aren't gonna be needing that for now. So just click the part button up here, and we're gonna scale this part up just a little bit, and I'm gonna color it pink. So it's just a pink part, and we're gonna name this part pink part with a capital P on both of those words. Now, so make sure to pause and bounce around this video, by the way, parts that you might have forgotten when you need them. This is gonna have a ton of chapters, so you can bounce around the timeline. It'll all be cut up to all the different definitions and everything, so it's really helpful and useful for you. Now, we're gonna right-click this part, click Insert Object, and we're gonna add a script into this, which is at the very top usually, or you can just type in script if you don't see it there. Now, we're gonna open up this script. So now, we're just gonna delete everything that's here, and we're gonna type in local pink part equals script.parent. Now, the first thing we're looking at is variables, and what we have just written out is a variable. A variable just stores a value, so the variable pink part stores the value script.parent, which is, well, the parent is just whatever the script is inside of, so that would be the pink part. So that's what this variable equals. This variable equals pink part. By the way, make sure that you write this exactly as I did. A lot of things in scripting are very case sensitive, so it's very important that you write this in how I wrote it with the uppercase and lowercase. It'll all make sense eventually. But a value in a variable could be anything. It could be an instance, which is just an object in Roblox Studio, like a part or GUI. You could also make it a line of text, which is called a string in scripting, or you could even make this equal to a number. So now let's make a new part. But wait, do not close this script. We're gonna make this part using scripting. So what we've done is we've already made a part normally, and we defined it through our script with a variable, but now we wanna create a part with our script. So what we're gonna write is local part equals instant.new, which makes a new instance, and then we're gonna type parentheses, and we're gonna type in a quotation mark, and then we're gonna start typing part and click enter. Now I'm gonna use my arrow key, go out of that, click enter. All right, remember, case sensitive. Now this variable is telling the script to make a new part, and we can basically make any kind of object in Roblox Studio with this too, but this part doesn't know where to go right now, aka what object it's gonna be parented to. And again, the parent is just whatever it's inside of. So right now we're gonna parent this object, this part, to a different object in Studio. Now right now the parent of the part is nothing. And in scripting, we write nothing as nil. So part.parent equals nil. That's already what it's at. So if we change it from nil or nothing to, let's say, game, which is just the whole game that we're editing, dot workspace. So everything inside of the Explorer here is in the game, and inside the game is workspace at the very top, which is where we see all our parts. So this part is going to go into workspace, and it's going to be visible in the game when we run the game. It's not going to be visible until we start playing the game. Parent is actually just a property of an object in Studio, and a property is just one of these details on a different object in Studio. So there's like color, shadow, cast shadow, color, material variant, reflectance, transparent. These are all properties of a part. So what we're gonna do is we're gonna change another property of this part. So we're gonna make a new line just by going to the end of this and clicking enter a few times, and we're just gonna write part.transparency equals 0.5. Remember to use that autofill. You can start typing something and just click enter and write like that. It will fill the rest of it in. It's really useful, makes scripting a lot easier. Now let's go to the top of Roblox Studio and click the play button and let's test it out. And there we go. So we had a new part fall right here. This is a 0.5 transparency part, and yeah, it's a pretty cool example of how you can use scripting to make a part in Studio. All right, so now we're gonna stop the game. We're gonna go back. Congratulations on your first script. Now you can feel free to pause the video and mess around with any other properties you want with your script, but right now we are going to be moving on to looking at Boolean. And Booleans are basically any checkbox in Studio is actually a Boolean. So as we can see here, cast shadow, which chooses whether or not this part has a shadow on it. As you can see, when we turn this off and on, it switches whether or not this has a shadow. Now, actually, what this means is cast shadow equals true. So when it's checked, cast shadow is true. If cast shadow is unchecked, that means cast shadow is false. That's just how we write it in the script. So cast shadow true, cast shadow false. So if we go ahead and make a new line and write part.cast shadow equals false, then this part will not have a shadow. If we change this to true, it's gonna have a shadow. So I'm gonna leave that at false, and we can mess around with a few other properties. So part.anchored equals true. If we do that, then it means that this part is just, it's not going to move or anything. We're gonna be able to push it around with our character. You probably already know what anchored means. It's gonna be stuck. Now, one other thing we can do in Studio is we can make the script wait. So we could actually go up in the script a little bit and we can make the script wait to make it anchor. So if we type in wait and then we type in a number, and by the way, numbers in Studio do not have quotation marks, but strings do. Strings are the lines of text. Numbers do not have quotation marks. So just remember that whenever writing a number down, you do not put quotation marks. Now, this is going to wait 5 seconds before it makes the part anchor. So all the other code before it is going to run, and then it's going to start waiting for 5 seconds and it's going to anchor the part. Now, this is a little bit more advanced, but to make this a little bit better for your performance on your game, there's actually a new feature in Studio that's called task.wait, and you'll usually want to use task.wait if you aren't doing something that needs to be very exact. Wait makes it exact and it forces the game to wait that long, but task.wait basically will let the game work at its own pace. It just might be like 0.001 seconds off. I usually tend to do task.wait when I can because it's just a little bit faster. All right, so now most tutorials would have actually shown you this first, but let's take a little bit more of a look at strings. So something that you can do with strings is print a line of words in the output, which is a window that spits out warnings, errors, and prints from your scripts and Roblox Studio itself. So if we go ahead and type in print and then we add parentheses, and then we can type in a quotation mark, and this is gonna make a string for us. So we can go ahead and write hi, and then when we run the game by going to test and then click on this drop down on play and go to run. Now in the output of Studio, after 5 seconds, the wait in our script, it's gonna say hi down here. Now that's pretty cool. And we can also print numbers. So we go ahead and print 5. The same thing will happen. This will work just fine. And by the way, you can put numbers in strings. So if we said hi 5, this is still gonna work. When you're writing a number by itself, you don't put quotation. Now this is mostly useful for when you're trying to debug your code and you wanna mark where certain things happen. So like after the part is anchored, we could put a print and we can say part anchored. Now, every time that happens, we'll know the part was anchored. And if we do not see this in there, we'll know that for some reason, maybe there was an error in our code, the part did not get anchored. And that's what you're gonna be using print for most of the time. Now in scripts, we can also do math, and we can print numbers and strings in the output, and we can also print math in the output. So we can actually print 3 plus 3. Let's see what happens when we press run on this. So after 5 seconds, again, after our wait is over, that's gonna do this. See, it prints out 6. 3 plus 3 equals 6. So it's gonna print that out. Now, make sure you do not put quotations around this, just like I said, because we are writing a normal number here, and this is not a string. And it's really important that you don't do that when you're doing math. We can do a lot of other things. We can also do multiplication, and to do that, we can just do a asterisk or a star, a little star. It should be on the 8 on your keyboard. You just hold shift and press 8 and you'll get that star. And if we do 3 times 3, well, it's gonna print out 9. And we can do this with division as well. So if we change the star to a slash, it'll divide 3 by 3 and we'll get 1. And there's a lot of other cool things that you can do in math in Roblox Studio, but we're gonna get back to this later because now it is time to move up to the next level. This is where things start to get intense. Well, not really. Just focus and follow along. This is where you're gonna be able to start making things really work in your game, and it's going to be incredible. So make sure you do not click off if you want to become a scripter. I see that mouse of yours inching closer and closer to the YouTube homepage. Don't do it. Don't give up on your dream of being able to script your own game, because this is well worth it, and it could end up being a real money maker for you later. Now we're on to function. Functions are exactly what they're called. So I'm going to go ahead and just click Control A and delete everything so we can start with a fresh slate. Basically, functions are just a piece of code that performs a function. Now, and this is just an action in your code, and it's when you call upon it. So basically, we don't want to be sitting there just typing the same code over and over and over and over and over again. So that's where functions come in. And they have a few other cool things that you can use them for too. Functions can be called upon with just a single word, and it will run your entire function, your entire chunk of code that's in that function, without having to rewrite it or anything. All you need to do is call the function by writing its name and parentheses after it. But there's also another neat feature. Let's say you put something into a function. Well, you can actually put a value into a function and it can spit something back. So you can have a function that adds 2 to whatever the first parameter or input in the function is, and it will go ahead and print that. So it'll add 2 to whatever you put into it and it'll print it. A parameter is basically just a variable when you're using it in your function. And trust me, this is going to be a lot more useful later, and it's also going to make a lot more sense when we actually write this out. So don't worry, we're going to make a function right now. So let's go ahead and write function add 10 x. So x is going to be our first parameter. So that's what you're going to do when you call the function. You're going to input x, which will be whatever number that you want to add 10 to. We're going to go ahead and add parentheses to that and type x again, and we're going to click enter. And we're going to write local y equals x plus 10. So what this does is this makes a variable y which equals our input x plus 10. That's what it's doing. So it's making a variable y and it just adds 10 to that, and that's what y equals. Y is just x plus 10. Now what we're going to do is we're going to print y. So this is going to print x plus 10. So if x equals 2 and we add 10 to it, that's going to be 12. So what y is going to be is 12, and it's going to go ahead and print that. And then what we're going to do is we're going to return y. And what this will do is it's going to basically, wherever we call the function, we're going to be able to use y later in the script. Also, what I did right here is I wrote a comment. You just put 2 dashes and you can write whatever you want, and the script is going to ignore this. So you can write notes, and it's pretty good practice to just write these wherever you can so you remember what things do in your script. And also it helps if someone else is going to be looking at your script later down the line. So functions are one of the most powerful things in scripting, and one of the most important pieces of functions is called scope. And you might have noticed so far that I write local before basically all variables. Well, you can also write local before functions, and if you don't write local, that means it's naturally a global function. So a global function can be used throughout the whole script no matter where it's written. A local function can only be used after it's been written, or if it's inside of a function, you can only use it inside that function. So we can only use y here inside this function unless we return it. And also, if we write a local function at the end of the script, for example, we can't use it anywhere at all. Same for functions. If you wrote a local function at the end of a script, you could not use that function anywhere unless you change it to a global function. So this is going to be a lot easier to understand after we practice a little bit more. So if we want to go ahead and use this function that we've written here, we can actually type in add 10, and we can type in right here in our x value. So let's write 2. So what it's going to do is it's going to print 10 plus 2, which is 12, and it's going to return that for us. So we can actually write local number equals add 10 2. And what this is going to do, since we returned y, this is going to equal y. This variable will equal 12, and we can go ahead and use that throughout the rest of our script, which is why this is so useful, especially when you get into the more advanced sides of scripting. So hopefully you understand functions, but if you don't worry, we're going to get a lot more practice in after this. This is just a brief explanation, and again, feel free to rewind, rewatch any parts of this video that you need, and remember, do not give up. You are well on your way to becoming a great scripter, and don't worry if you don't understand everything yet. This video will clear up all your questions by the end. So next thing we're going to do is we're going to look at if statement. If statements basically check if something is true, and if it is, it does it. So, okay, so we need a variable for this part. So local part equals script.parent, which is our pink part. So local part equals script.parent. And what we're gonna do is we're gonna do if part.anchored equals 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 basically just means that it's checking if something is true. You need to do that whenever you're checking if something is true. If part.anchored equals equals true, then part.color equals color3 dot from RGB 255 0 0. So what this is going to do, this is just color 3 is just a 3-number value that makes a color. And if it's from RGB, it's going to be making it in red, green, and blue, and the highest number being 255, lowest being 0. So if we write 255 on red, it's going to be a fully red color. If we were to add 100 of this, it'll make it a little bit pink since we're adding a lot of blue. If we added a lot more, like 220, it'll make it more purple since red and blue usually makes purple. Alright, so what this is doing is it's checking if the part is anchored, and if it is, it's changing the color of the part to red. Now, we can also add to this and we can make it check for something else. So if this is not true, it's just going to skip the changing of the color of the part altogether, but we can make this move on and say else. So if that isn't true, it's going to move on and it's going to say print part is unanchored. So it's going to print that the part is unanchored. So if it's anchored, it's going to make the part red. Otherwise, it's going to print part is unanchored. And honestly, this is one of the most useful things I use all the time in scripting, because there's a lot of times we need to check things are true, check if things aren't true, check if things exist at all in your game. And we don't have to just check if something is true. We can actually check if part.color, if part.brickcolor equals brickcolor.new, and then, oh yeah, we got to do the double equal signs. I'm forgetting too. It's easy to forget. If part.brickcolor equals medium stone gray, then we can print this is a gray part. And this is going to write in the output that this is a gray part. As you can see, this doesn't even have to be a whether or not this is true, because obviously we can't have a if part.brickcolor equals true. But if the part.brickcolor equals brickcolor.new medium stone gray, then it's going to print that this is a gray part. And otherwise, it's just going to skip over that code just like all if statements. Now, there's also else if statements. So what we've looked at so far is if statements with check if something's true, and if it is, it does it. We looked at else statement, which it just moves on. So basically, if that isn't true, it'll move on. It'll do whatever else is in the script. But what else if does, it's like else, but then you're also checking for something else. So if part.anchored equals false, then it's going to print part is unanchored. So this already, it does the same thing, but it's checking for something specific. So if we did this on something a little bit better of an example, is doing it on the brick color. So else if part.brickcolor equals brickcolor.new really red, it's going to check if this is medium stone gray, and if it's not, it's also going to go and check if the part's color is really red, and it's going to print in the output this is a really red part. So as you can see, this can be very useful. So if part.brickcolor equals brickcolor.new medium stone gray, then it'll print this is a gray part. Otherwise, it's going to check if this is a really red part, and if it is, it's going to print this is a really red part. Otherwise, it's going to skip both of these things altogether. And that is why else statements, and if statements are all just as useful. There's just different scenarios when you're going to need to use them, when you need specific things done in your script. So now we are just going to completely ditch this script for now. I'm going to close it out, and I don't want this script doing anything for now. I don't want to delete it though. So right now I'm just going to actually right click, rename this script to not using this, LOL, and I'm just going to click disable in property. So this script is not going to do anything. And we're going to make a new script by right clicking this part, clicking insert object, and clicking script. And it's going to go ahead and make a new script. So let's clear out the script by clicking Control A and just clicking backspace. And we're going to write if script.parent.name equals taco, then print taco. Else if script.parent.name equals hamburger, then we're going to print hamburger. So what this is going to do is this is another if and else if statement, and this is going to check if the part's name is taco, and if so, it is going to print taco. If it is not taco, it is then going to check if this is a part named hamburger. Otherwise, if it is not named hamburger, it's going to do nothing. If it is, it's going to print hamburger. Else will always do something. If the first if statement is not true, else is always going to do something. So if we do else, it's going to print hamburger no matter what. no matter what the name of the part is. If it isn't taco, it's always going to print hamburger. But if we add on that else if, it's going to be checking for something specific, and it's going to print hamburger only if the part's name is hamburger. So hopefully that clears up the difference between else and else if. I know it's kind of hard to get at first, but it's very important that you know the difference because you're going to be using both of these a lot in script. All right, we're done with that. Enough with the else and else if. So next are events, and events are really cool. Events are really interesting because we can finally start to check and like listen for when things are happening in our game, and we get to have script that run when something happens in your game. So let's say a player touches a part. We can have an event of when a player touches a part. We can run a chunk of code when that part is touched. So what we're gonna do is we're gonna go ahead and make a new part. We're gonna make a kill brick over here. So I'm gonna go ahead and add a part, anchor that thing, scale it, and I'm gonna make this, you know, a nice little red, and we're gonna add a neon to that. Nice little kill brick, cool looking. I wanna turn off cast shadow on that too, just for the heck of it. And I'm gonna click the plus on the part, and I'm just gonna add a script into this by clicking on it. And I'm gonna clear the script out by clicking Control A, clicking backspace as usual. And I'm also going to name this script. I want to name this kill part script. So first we're going to define our variables, and we're going to write local kill brick equals script.parent. So what we're going to do is we're going to add an event that basically it's going to check when some other part touches this part, and then we're going to check if that part is inside of a player's character. We're basically going to check and listen for when a player touches this part. And then we're going to go ahead and kill that player's character. So we're going to go ahead and do that. So we're going to listen for the touched event, and we are going to make a function that passes on the touch part, which is the part that touched the part, and we're going to write that as a parameter. The touch part parameter is going to pass on to the function, and it's going to tell our script the exact part that touched it. So we're going to go ahead and make this function. So killbrick.touched, which is the touched event, and we're going to write a connect, click enter, and we're going to type in function and then add parentheses, touch part, and going to go to the end of this. We're going to go to the right in between these two parentheses, and we're just going to click enter there. I'm going to click enter 3 times just so I have some space. And so what this is going to do is, as I said, it's going to listen for the touched event, pass on the touch part parameter to this function so we know what part touched this part, and it's going to tell our script the exact part that touched it. And now we're gonna do the killing of the humanoid. So we're gonna do local humanoid equals touch part dot parent, so whatever the touch part is inside of, and we're gonna do find first child. And find first child is a built-in function in Roblox Studio which we can run on any object inside of the game, and it will basically just loop through and check each child of an object in Studio, and it will check whether or not an object with a specific name is inside of that part. So it's going to find a child with a specific name. So we're going to find the child called humanoid. And a humanoid is what controls all the aspects of a character, like its health, how high it can jump, how fast it can walk, everything like that. And what it's going to do is it's going to see if we have a humanoid. And if it does, it is going to say, okay, here's the humanoid, and this variable is going to equal humanoid. If there is not a humanoid, this is going to equal nil. So what we're going to do now is we're going to check if there's a humanoid so we don't get an error. If we don't check if there's a humanoid and there doesn't end up being a humanoid for whatever reason, like if let's say a part that wasn't a character touched this part, that part isn't going to have a humanoid. If it touches it, it's going to error out if we don't have this if. So that's why we're doing find first child. It checks if there's a humanoid. And now we're going to do an if humanoid. That's all it is, if there's a humanoid. And basically, by the way, nil and false are the same thing. Writing nil, if nil, that's just like writing false. So if false, basically. So if this is nil, it is going to not run this code. But if there is a humanoid, it's going to run it. So hope that makes sense. So if humanoid, then humanoid.health equals 0. And that's it. So we're going to go ahead and play the game, and let's hope this works. So I'm going to go back to my base plate, I have play here pinned up here, and I'm going to click play here. So I play right on it, and when I touch this part, it is going to kill my character. There we go. So we have a perfect obby kill brick all made for our game here that we're making. And by the way, by the end of this video, you're gonna know how to make an obby. Did I mention that? We're gonna be making an obby. Yep. You're gonna be making a game in this first video. You're gonna be scripting your first game. It's amazing. I don't wanna get too cocky, but I'm gonna say this might be one of the best scripting videos out there, because I'm gonna condense all the information into one video, and hopefully you will be a scripting pro by the end of this video. That is my goal. So that was pretty easy, right? Now, a lot of things in Studio have built-in events. So I'm gonna open my script back up. And these built-in events, we can actually see them with the object browser in a nice list. So if we go to View, Object Browser, this will open up a new window and we can flip around these. And this will basically show all the objects in Roblox Studio and everything that exists. So if we can find part in here. Now I wish there was a search on this. That's the only thing. There's part. Okay. If we find part in here, we can actually see, so in here, the lightning bolts are all the events on the part. So we can listen for all of these events, not just touch. We can listen for touch ended. So when something stops touching it, or when the part is getting destroyed, when a child's added, when a property is changed. There's all kinds of events on different objects in Studio, and every object in Studio has tons of different events that are unique to it. So there's a lot of cool things we can do with events, and it doesn't just have to be touched. We could listen to any event we want. So we could say touch ended, and when something stops touching it, it's gonna check if that part has a humanoid, and it's gonna kill it too. Now, I'm not sure if this always works. I don't think this is that reliable, but again, there are ways that you can do that. That's just an example. There are a lot of events, and we can use these for a lot of things. By the way, quick reminder, you are doing great. You are getting really close to becoming a full-on scripter, and you got to keep going. Do not give up. So we're getting on to the next detail, which is random numbers. Random numbers, I mean, they're self-explanatory, but they're really useful for a lot of things, and especially for waiting a random amount of time. So for example, if we want to wait a certain amount of time after the player touches this part to kill them, we can do, of course, task.wait, just so we have that good performance benefit of using task.wait versus wait. And then we can just do math.random, and then add parentheses. Then what you do is you write the minimum number here. So let's do task.wait math.random 1 second, and then comma 10 seconds. So what this will do is it'll pick a random number between 1 and 10 seconds. All right, so after this, I want to take a look at loops. Loops basically just let you repeat things forever, or for a certain amount of time, or until something is true. There's a lot of ways that you can write loops. So one way is a for loop. So let's go ahead and make a new script. I'm gonna make a new part, anchor that, and then I'm gonna hit the plus, add a new script. So the for loop, as I said. So the for loop it will loop through a number or a table. So it'll count up from 1 to that number. If we do for number equals 10, so it's gonna count up to 10, repeat. Basically, it'll just repeat this 10 times. For number equals 10, comma 1, do. For number equals 10, comma 1, comma 1, do. Script.parent.size.x equals script.parent.size.x plus 1. So what this is going to do is it's going to add 1 stud to the x size on the part 10 times. And I'm just going to add a short wait between them. So wait let's do wait 0.5. Oh, task.wait, don't forget that. And we can go ahead and test this out. Oh, actually, you have to do number equals 1, comma 10. I was wrong. It's the other way around, and we don't need that third one. But if we go ahead and test this, it should work now. Oh, another mistake. I keep making mistakes. I know the problem. Script.parent.size. We need to make this a vector 3. So a vector 3, as I said earlier, a vector 3 is just a 3-number value used to show usually positions with parts or sizes. Vector 3.new. And then just add parentheses around that. And then the first value is x, then we're just gonna do y. We'll just copy this script.parent.size.x and change that to y. Same thing, except we're putting z on the last one. And now it should work. Finally, worked out all the bugs. And as we can see, it's working. Now it looks like I made my wait a little bit too short, but as you can see, it added a lot of studs to each side, and it definitely grew by 10 studs. So that's how for loops work in the most basic way with numbers. For loops can also loop through a table. And so for example, we can do for game get service players get players for I, comma v in pairs. So what this will do, if we write this for I, comma v in pairs, parentheses, game get service players get players. What it will do is it will get the players from the players service on Roblox, and it will loop through each player, and we can do whatever we want to this. So what v does is that will equal the current player that we're on, and I is the table. The table is just the list of all the players we've gotten from the players service. So if we say v.character destroy, now this probably isn't going to work since we do have to wait for the character. So if we do v wait for child character, or if we do v.character added connect function, so what this will do is it'll destroy the character every time it spawns. Now, obviously we don't want this, but as you can see, this can be very useful to be able to loop through a list of things, especially players. Like when you're making a mini game system, you might need this, or a lobby system. It comes in handy a lot, so we definitely recommend practicing this so that you can use it when you need it, because trust me, this is definitely something I use constantly. I make hundreds of these every time I script, it seems like, so you're definitely going to want to know these. Now next we have while loops, and with while loops we can just do while something is true, do something. So we could say while script.parent.anchored equals true do. As long as this part is anchored, it'll repeat this, and it'll stop when the part is unanchored. Now, a lot of people will just use while loops for looping forever. So while true do. So basically this will just make it repeat forever, because true is, well, it's always going to be true, and it's checking if whatever this is true. It's a little bit hard to explain, but basically it just means it's checking if true is true. And yeah, true is true. It's always going to be looping, so you can have this loop forever. Now, whenever you do one of these, I do recommend always having a wait of at least nothing. So if you do that, it'll do the shortest possible amount of time that it can wait, and you need this, otherwise Roblox Studio can crash. So, or your Roblox game might crash too if you have a loop. And you want to keep these down, and you definitely want to be careful with these because they can cause a lot of lag, especially if you don't have that wait in there. If we ever want a while true do loop to stop, we can actually add break, and what break will do is it'll just stop it, and it'll continue on with all the code in front of it. Now, we probably do want to practice this while true do loop. If you don't want to practice this, you can always skip ahead to the next chapter on the video timeline, but this will be really quick. So we're just gonna make hearts rain out of the sky. So local part equals instance.new parentheses part.parent equals game.workspace local random x equals math.random -200 comma 200, and then local random z equals math.random -200 200, and then we'll throw all those positions together into part.position equals vector3.new random x comma, let's say 50 studs in the sky, and random z pass.wait. We'll just do the shortest one. We'll see how laggy this is gonna be, like a lag test on my computer here. Let's go ahead and play this. And as we can see, hearts are raining out of the sky. So that was mission successful, and that is one cool example of how you can make while true do loops and use them effectively in your game. Yeah. Now I promise we are almost done with the math. Almost. But I need to give you guys an example for how to use a break. So we probably want this to stop raining parts at some point, otherwise our computer is gonna absolutely crash. Well, first we probably want to add debris. Basically what this does, it'll automatically make the part delete itself after a certain amount of time. So let's look at debris service up here. So debris is a service. Local debris equals game get service debris. And what we'll do is we'll get debris and then add item part lifetime. So what this is we'll just make this last let's say 20 seconds for each part. And now what we want to do is we want to make this break if there's 400 total parts in workspace. So what we want to do is we can actually just add a part count. We want to do that outside the loop. Local part count equals 0, and then we'll do part count equals part count plus 1. And if part count is greater than or equal to 400, then break. We probably want to put this at the top here. All right, so next are tables, which you might have seen, you've probably seen these before visually or in a school document, but These actually can be made in scripting too, but they're quite a bit different. But it's actually pretty similar to a table on a document if you want to look at it that way. You'll see it has rows and columns, and this is very similar to how tables work on Roblox scripting. We use them to store large amounts of data and then loop through them very quickly with for loops, which I just showed you. And they're extremely useful. They come in pairs. So if we look at a visual table, we can see that there's a row, and then we could have a number right next to it, and there could be a value in the next column over. This is called a key value pair. A key being the row number or the row name, and the value is just whatever piece of data, that could be a string, a number, a picture, whatever piece of data is associated with the key. Also, the key doesn't have to be a number, neither does the value, as I said. So let's go ahead and delete this. You don't have to, you can just make a new script, but I'm gonna delete mine. And let's make a new table with a variable. So local, we'll make a fruit table. So local fruit equals, and then what we do is we hold shift, and then right above the normal brackets like these, right above that, if we hold shift, we'll get these. This gives you a table bracket. So just go ahead and click enter a couple times. Okay, so the first key will be bananas. Equals 1, and then you add a comma, or you can do a semicolon after that. So what we've written here is that there's one banana. So if we go ahead and reference this table later, we get to see, oh, hey table, how many bananas are there? It's going to say 1. It's going to return 1. So next we'll do apples equals 5, oranges equals 2, and that's it. So the keys in this table are the names of the fruit, and it equals that number of fruit there are. So there's 1 banana, 5 apples, 2 oranges, and to access one of the values in the table, we just write fruit at these kinds of brackets, and then we can write whatever name of fruit we want, which would be our key, bananas, equals fruit, bananas, and then we can add 5 to that. So what this does, oh, we do need to add quotations around this, almost forgot, because it is searching the table for that. So this is just like find first child, which loops through a part's children, but this, rather than looping through a part, it can loop through a data set like a table. This is really just dipping our toes in tables, and there's a lot more we can do. We can loop through a table with an in pairs loop and check for a certain value like I showed earlier. And find first child is a built-in function in Roblox Studio that actually loops through every child or part inside of another part, and it searches for one with the same name that you input into it. Everything in Studio is made up of tables, literally everything, like the children of every part, which are just the items inside a part. Even the properties of parts are pretty much in tables. This is why tables are extremely important in scripting on Roblox or not. So with that in mind, we can actually loop through the children of a part with the getChildren function, which returns all the children of the part in a table for us. So let's first find some stuff we want to remove. Let's first add some stuff that we can remove. So let's add a bunch of particles to this part here. This poor part, we're gonna add a particle emitter. I'm just gonna duplicate that a million times. And I'm gonna go ahead and delete everything we did here. And let's do a for IV in pairs loop, looping through all the children of this part. And we're gonna check if each object is a particle, and if it is, we're gonna destroy it. It's gonna be gone. So for I, comma v in pairs script dot parent get children do if v is a particle emitter, then v destroy. The reason why we want to check if it's a particle emitter with is because we don't want to accidentally delete the script. That would screw some stuff up. So we want to make sure that we're checking if each thing is a particle emitter. If you want to check if something is a part, for example, which you're going to need, you can actually just check if it is a base part, and that will check if it is a part of any kind. It could be a mesh part, wedge, doesn't matter. It could be a normal part. It will make sure that it is a part of some sort. And it helps because you don't have to check for each kind of part. You just check for base part. Just need to throw that in. So I'm gonna leave it as particle emitter, and let's go ahead and play. Oh, that's a lot of particles. We definitely need to get rid of those. So if we play the game, and if they're all gone, we'll know it worked. And as we can see, it's perfect. No more particles. It worked perfectly. So this is definitely one of the things I'm used the most in scripting. Constantly. I can't emphasize enough. This is one of the most important things, and you're going to want to practice this a lot. You're almost there. You are almost a scripter. Do not quit now. If you click off the video, you're probably going to forget everything really, really quickly. So we got to practice. Right now, let's practice by making a quick obby. So an obby is a good practice because we can just make a bunch of obstacles, do whatever we want with that. And we already made the kill brick, so why not use that as our first obstacle? So we have this component. So I'm gonna go ahead and start building an obby. So we can just add this in there, scale it up, and let's anchor this, make it a little bit darker, and let's raise this up. And I'm gonna turn on my increment to 1 stud, and then I'm just gonna duplicate it a couple times, and there we go. So I wanna go ahead and make sure we're organized by, oh, this is way uneven. There we go. So let's go ahead and make sure this is organized by adding a folder into Workspace, and just gonna rename this to kill part and just drag them all in there, and there we go. So, oh, this isn't the kill part. Put that back into Workspace. So now we do have a problem. We have all these kill part scripts inside of each one of these parts. This is a kind of redundant. So what we're gonna do is let's delete all of these by selecting them all, clicking select children, and then just hitting backspace and deleting them all except for one. And I'm gonna move this into server script service. And in this, I'm just gonna change a couple things. So let's change killbrick to killbricks folder. Let's change the variable to reference the folder. So what I'm getting at here is that we're going to use a for loop to loop through each part and make it so whenever that part is touched, it will kill the character. So game.workspace.kill part, and then we're going to do our for loop. So for underscore comma v in pairs kill bricks folder, get children, and then arrow key out of that, do. And then let's just select all this, hit Control X and paste that in there. And let's just change V. We can just change V to kill bricks. Underscore will just mean that it isn't counting like how many kill bricks we've already looped through. It just won't save that table. It's just a little bit better on performance to do that if you don't need that number. Like sometimes you might want to check which kill brick you're on, for example, and if it's on the 5th kill brick, maybe you want it to stop or something. Well, we don't need that right now, so that's why I did that. Better for performance. So we changed V to kill brick, and V is just the item we're on currently in the table. So right now it'll be the current kill brick, and replacing that in this script should work perfectly. Oh, and we should delete our little practice wait there if we have that still. And there we go. So now our kill parts will work. And now maybe we should make some checkpoints. So let's go ahead and make a new checkpoints folder and rename that to checkpoints. And let's go ahead and add a part. Oh yeah, before we do anything else, let's make sure they're all anchored. And I'm gonna go ahead and scale this down. As you guys can see, I'm probably not the best at building obbies, but there we go. Let's honestly make this neon, and then I'm gonna make this like white. Yeah, there we go. I don't want too much glow on it, so I think smoky gray looks like a great color. And next, let's start scripting this. So let's add a new script into server script service, and let's rename it to checkpoints script, and we're gonna do the same thing as we did before. So local checkpoints folder equals game.workspace.checkpoint, and for underscore comma v in pairs checkpoints folder get children do. If v is a base part, so that checks if it's a part of any kind, then v.touch connect function. And now we need this to do something. So let's define that player real quick. So we're gonna do connect function part. Okay, we'll do part. And then if part dot parent. Here, let's go ahead and add the player service because we do need to check if this is a player. So local players equals game get service players. And we'll do if players get player from character part dot parent. So that'll check if the model that the part is in is a player. Oh, wait, actually, I keep changing things. But we're gonna cut this, select it, hit Control X, and let's do local player equals. Just a little bit better, so we don't have to do it again. So if player, then what we're gonna do is we're gonna add a stage to that player, and we're gonna check if they haven't already touched that checkpoint, or we're gonna set it to that number of checkpoint. So what we want to do is drag our checkpoint in here, and we're going to rename this to 1. So we'll just have the checkpoint number be the name of the part. Now we do need to set up a leaderboard real quick. So this will be really easy. So what we're going to do is we're going to make a leader stats. It's going to save what stage they're on while they're in game. It'll reset once they leave, but this will make it so that when you join the game, it's going to make you a stage number. So local leader stats. Oh wait, no. Game players dot player So players dot player added, connect function, player, local leader stats equals instance.new folder, leader stats dot parent equals player, local stage equals instance.new int value. So this will make a new integer value, which is just a number, no decimal. And it will save what stage it's on. And we're going to put that in leader stats. So it will show on the leaderboard as stage and then the number. So stage.parent equals leader stats. And that's all that's needed. So if player, and let's make a variable for their stage. So local stage value equals player.leaderstats.stage. If player and stage value is less than toNumber, so toNumber will make this to a number, v.name, so that'll check, so the name of the checkpoint, and that'll get the number, the name of the checkpoint, it'll turn into a number, and it will check if the player is not on a stage that is greater than that. So we don't want them going back stages. That's basically all this does. And it'll set the stage value. Oh yeah, we do need to do stage value dot value, because stage value is a object. It's the int value. We have to do the dot value because it's a property. So stage value dot value equals v.name. Okay, that was a lot. If you did not catch it, feel free to rewind. And feel free to pause and copy down what I have if you missed it. This should set up our checkpoint in our game. So if we go ahead and play right here. Oh, we didn't name the folders here. We have a little problem. We did not name the folders. Leaderstats.name equals leaderstats. And stage.name equals stage. There we go. Another error. I didn't capitalize that. Oops. This is the hardest part about scripting, most annoying part. There's a lot of bug fixing and little annoying things like that. Like one capitalization can screw up your whole script. It gets annoying, but there we go. Finally, it works. So we touch this, and now we're at stage 1. We die when we touch a kill brick, and that is good. We do want to make sure that we move the character to the checkpoint when they respawn. So if we do player.character added, connect function character, or just juchar, local checkpoint equals checkpoints folder, find first child, do stage.value. So if it finds the stage value in the checkpoints folder, it's basically checking if their current stage even exists. Then we're gonna do player.primary part, and what this does is it'll get the humanoid root part, stumbling over my words, humanoid root part, or the torso if you're using R6, and it will move to where we want it. So player.primary part.cframe equals, so C-frame is just the way we do positions and rotations, all in one nice value in Roblox Studio. It's kind of weird and complex. I mean, I don't even completely understand it. It's a very complex subject, C-frame, but with the C-frame, we're just gonna go ahead and write cframe.new checkpoint.cframe.rotation equals .cframe. Okay, checkpoint.primaryPart.cFrame.position.y plus 5. So we're adding 5 studs so they spawn above it. I'm making this way too complicated, aren't I? Checkpoint dot. Okay, let's hope this works.
A few moments later.
And of course it didn't work. Oh, okay. Player.primaryPart.cFrame. No, that needs to be player.character.cFrame. I screwed a lot of things up here. I'm gonna be honest with you guys. I don't know how to make this respawn right. But I think you guys get the point of the obby. I don't like making obbies. When in doubt, go to the Dev Hub on Roblox. It's a great time for me to do it, but you can go to the Dev Hub. So you search for Roblox Dev Hub. developer.roblox.com. When you go to this, you can find info on everything. And when you can, you want to go from here. Or sometimes when you Google a question, you can find a question answered on Dev Forum or Scripting Helpers, but usually you're going to end up back here. So you want to try and read this when you can, learn some stuff about scripting. And if you want more advice on how to get commissions on Roblox and how you can earn tons of Robux from scripting or whatever you'd like to do, make sure to check out the video on screen. See you guys there.